There are three different types of plate movements that we'll discuss, the first being divergent plates here in 6.4. Each of the three types of plate movements are illustrated in one of these boxes here. The one over here on the right would be showcasing divergent plates where we have arrows that are going in opposite directions, or in other words, separation occurring. I'm going to use very complex illustrations, sarcasm, to illustrate divergent plates. So we're going to have a plate that's going to be separating into two individual plates, which is clearly evident here, as the plates move further and further apart from each other. What is it that creates that separation? That's going to be the focus of the rest of this discussion. A simple way to visualize what causes this separation is if I have this wedge here, this orange wedge, if I hammer it from below, if I pound on it from below, what's going to happen is it's going to go up and, of course, cause separation to occur. A very simple way to illustrate kind of the basics of what happens in divergent plate boundaries. We go back to the plate boundary map and we can see in this box here the country of Iceland. The country of Iceland actually has separation occurring right through the middle of the country. And if we zoom into Iceland, we can see that actually the North American plate and the Eurasian plate are separating from each other. And so this ridge, this separation, this divergent plate boundary that occurs right through the middle of the Atlantic, actually we can see here when we look at an image. And so knowing that we're looking to the south here in Iceland, this bridge across this rift or across this valley in the southern part of Iceland, on the left-hand side essentially is the Eurasian or the European landmass. Over on the right-hand side is the North American landmass. I know this because we're looking to the south. And so one of the things we can see here is we can actually see a divergent boundary on Earth's surface, which is rather rare. There are other instances of this, which I'll showcase here in a minute in Africa, but for the most part these are going to be occurring below water. Let's nail down some key terms and definitions. First off, divergent plates, of course, these are tectonic plates that are separating from each other, spreading from each other, diverging from each other. Further, another key term, seafloor spreading or spreading centers are very critical to understanding continental drifting, continental movement. Because, for the most part, divergent plates occur underwater, we refer to them as seafloor spreading. I did provide an example previously of Iceland, and I will show one here in Africa of where seafloor spreading or divergent plates actually occur above water. However, for the most part, this is going to be below Earth's surface. What happens here is molten magma. We've already talked about this beforehand in video lecture 6.2, comes up through cracks in the lithosphere, comes up from the asthenosphere, through cracks in the lithosphere due to convection. And we can think of those as volcanoes, just to use a kind of a visual. And what happens is as it gets closer to the surface, it cools, it hardens in that void or in that crack or surface, and we now can go back to that previous illustration I showed of the creation of new crust as that hammer forces that wedge up, causing the separation to occur. And one of the things that you'll notice, a rift will occur, a separation will occur, and that separation will be lengthwise. So essentially we'll have a parallel separation that will occur, and we'll see various examples of this on the following images. Further, another characteristic we'll find along the middle of a sea floor spreading center is mid-ocean ridges. Mid-ocean ridges are also a characteristic of divergent plates. This is where we're going to find the location of seafloor spreading. One of the things that's kind of, you got to wrap your mind around is the Atlantic Ocean. You would think conventional wisdom would be way out in the middle of the ocean would be the deepest part of it. However, it's not the case because right through the middle of the Atlantic Ocean we have a mid-ocean ridge, we have divergent plate boundaries, we actually have an underwater mountain range. And so another characteristic of seafloor spreading centers are they do actually create these rather rugged mountain ranges, albeit underwater. We don't see the tops of these mountains, of course. One of the things you'll note in the following image is the youngest crust would be conventional theory, if it's creating new crust and that new crust is coming into the crack, coming into that separation, is going to be found near the center of a mid-ocean ridge. And we'll see that on the following examples. So the Mid-Atlantic Ridge is a mountain range that goes right through the middle of the Atlantic and is a great example of a mid-ocean ridge that we see actually on Earth. Here's a map that shows all the places on Earth where we see separation or spreading centers, divergent plates. And we can see that mid-Atlantic ridge that goes right through the middle of the Atlantic Ocean, separating Africa and the Americas. We can use this map here to illustrate where we would find the youngest rock. And so the youngest rock is indicated in red, the oldest rock is indicated in blue. So if we go right there in between Africa in North America, right there in the middle of the Atlantic Ocean, we can see the seafloor spreading. We can see that separation. And that corresponds to the mid-Atlantic ridge that we talked about. So Africa and North America, because of this spreading center being right through the middle of the Atlantic Ocean, are actually getting further apart from each other. They're slowly drifting further away. So what's driving that is there's this big crack here in which there's magma being brought up to that crack, which is causing it to grow wider and wider over time. And so what comes in to fill that void? New rock. And we can see new rock, the red, is found there right along the spreading center, where our older rock is found further away. I return now back to our main image we'll see time and time again here in video lecture 6, and we can see right in the middle a divergent plate boundary, that ocean spreading ridge, and we can see that lithospheric crack that occurs in which the asthenosphere then rises up through that crack, creating separation, creating a situation where we're going to have a divergent plate boundary, and we can see that there in the middle. Over on the right hand side we see another example of a divergent plate boundary, but this one is occurring on a continent. And so here we can see the same ideas, divergent plates, which makes sense because we see this in Africa, where there's actually a triple plate separation occurring. And so right here we have this area called the Afar Triangle. It's called the Afar Triangle because essentially in three different directions the plates are separating. So you have the Arabian plate going one way, we've got the African Nubian plate going another way, and the African Somalian plate going a different way. So we have three different directions in which these plates are headed, and so over time this is going to cause change in this area. One thing we'll note is Africa has Great Lakes as well. These Great Lakes also correspond to the locations of where these plates are separating. Now, why do we have lakes here? Now, if we think about this, makes sense. We've got rifting occurring, and so we're going to get gaps. We're going to get cracks in the surface. So if we get cracks in the surface that happen, in this case, above water, then we combine that with the fact we're in a tropical rainforest. We combine that with the fact we're underneath that equatorial low pressure trough a good amount of the time throughout the year, that ITCZ is constantly overhead. That makes sense why we have, in this case, these cracks being filled by precipitation, in a considerable amount of precipitation. One of the things we also know is these lakes here also are what is key to filling up the Nile River, which then, of course, makes its way to the north to the Mediterranean Sea. Here, once again, this is the plates. They're separating. They're going three different directions, and the yellow represents the gap between them. And, of course, that gap is continuing to widen and widen, to the point that Africa will actually break up, so much that the Indian Ocean, now that you know where the Indian Ocean is relative to Africa, will actually come in to fill this void, to fill this crack between these three different plates that are separating from each other. Here in this image from Africa, we can see actually the rifting occurring at the surface. And so this is more kind of a tension crack due to the rifting, but we're going to continue to see this area separating from each other. Of course, this is going to be way beyond our life expectancy. This is going to be millions of years. Here's a cool image that shows, it's been digitized and doctored a bit, but it's a cool aerial photograph showcasing the African Great Lakes that we find here in this rifting area in the Great Rift Valley. One of the things to note is this is not ocean water that we see here. This is, of course, rain that comes and fills the cracks in the low-lying areas, and that makes sense. This is a area that gets a ton of rain. It's a tropical rainforest. Now, up in the Middle East, of course, we've got separations. We've got Jews on one side, Muslims on the other, Christians on the other, but we also have plate separation occurring as well. This aerial photograph illustrates the separation here in the Middle East. It's occurring along two different divergent plate boundaries, both highlighted in the yellow lines. So along those yellow lines we have divergent plates. So essentially these water bodies that are found corresponding to these yellow lines are going to over time get wider and wider and wider and separate further and further and further, with or without our